Horizontal and vertical asymptotes. Let's review. In order to find a vertical asymptote, we're going to ask ourselves what is going to make the denominator 0. Now we have to simplify first. You might be able to simplify, you might not, but once you see the simplest form, you'll say what makes the denominator equal to 0. To find the horizontal asymptote, you have some choices. You're going to look at your degree. The degree is the highest exponent. You'll look at the degree on the top and the degree on the bottom. If the degree is higher on top, there is no horizontal asymptote. If it's bigger on the bottom, the horizontal asymptote is automatically y equals 0. And if the degrees match on the top and bottom, the horizontal asymptote is the leading coefficients over each other. Let me show you. All right, example 1 here. Let's find the vertical asymptote first. So we're going to ask ourselves what would make the denominator equal to 0. There's no simplifying to be done here, so 2 minus 2 would give us 0, so our vertical asymptote is x equals 2. Now when you graph it, you should be able to see it. You can type this in your calculator, just make sure to put the whole denominator in parentheses, and it should look like the graph I have for you here. Let's double check our vertical asymptote. Yeah, we can see that right about here, there is a vertical asymptote. Now for horizontal asymptote, we're going to look at the degree. The degree of the top, there are no variables. When we look at the bottom, it has a degree of 1. So a degree of 0 over 1 makes it more on the bottom. When the degree is higher on the bottom, it's automatically y equals 0. We can look at our picture and double check that we are indeed correct. The next example, vertical asymptote, we're going to look at the denominator and make sure that it's simplified, everything's simplified. Look at the denominator and ask ourselves what would make that a 0. Well, negative 1 plus 1 would give us 0. So we conclude our vertical asymptote is x equals negative 1. And if you plug it in your calculator, just make sure you put the whole numerator in a parenthesis and the whole bottom in parentheses before you press graph. It looks like this. Let's double check with our vertical asymptote at negative 1. Oh, there it is. Looks pretty good. Horizontal asymptote. The degree of the top, well, I don't see any exponents, but I know that x has an exponent of 1. This x also has an exponent of 1. When the degrees match up, then we use the coefficients. The coefficient of x in the numerator is 4. The coefficient of x in the denominator is 1. So my horizontal asymptote is 4 over 1, which is just 4. Double check with my graph. Yep, looks like there's a horizontal asymptote right at 4, just as we suspected. The next one here, when you put it into your calculator, if you want to look at the graph, make sure you put the bottom in parentheses. To do the vertical asymptote, we want to ask ourselves what would make the denominator 0. Before we do that, we always have to see if we can simplify. That reminds me of a difference of perfect squares. We can simplify this one to be x plus 2, x minus 2. So it looks like our vertical asymptote is going to be at negative 2 and positive 2. Double check it with the graph and you can see there are 2 vertical asymptotes, one at negative 2 and one at positive 2. Horizontal asymptotes, we're going to look at the degree. The degree of the top has no variables, so it's nothing. The degree of the bottom is 2. When the degree is higher on the bottom, it's automatically y equals 0. That's confirmed by our picture. There's our horizontal asymptote. On the bottom here, 2 to the x power. Vertical asymptote, it's not going to have one. None. There is no denominator to set equal to 0. Horizontal asymptote, y equals 0. Now we know this because of a little background knowledge about exponential functions. Exponential functions, remember, growth looks like the one we've got on the board. Decay would look this way and go down quickly, but regardless, unless you move it up, down, left, right, it's going to have an asymptote at y equals 0. Log of x looks like this. Vertical asymptote is at x equals 0. And it has no horizontal asymptote. Food for thought as far as the ones at the top go. I think it's kind of tricky to keep track of when it's y equals 0 and when it doesn't have a horizontal asymptote. So when you look at the top 3, Here's what I do when I need to remember. If the degree is higher on the bottom, it's y equals 0, and I remember a trusty snowman. You know how if you have a snowman, you always put the biggest snowball on the bottom? Well, doesn't that remind you of y equals 0? So if the biggest degree is on the bottom, then you think of my beautiful little snowman and think about how y equals 0 is going to be your horizontal asymptote.